The project consisted on analyzing a sour water treatment tower to evaluate if the water that comes into the plant is ultimately cleaned after various procedures. This evaluation was based on environmental regulations and standards, hence the process involves the removal of toxic wastes produced. The main process consists in the introduction of sour water, hydrogen, and atmospheric air in order to obtain treated water with additional streams of nitrogen, ammonia, hydrogen sulfide, sulfur, and carbon monoxide in small amounts. First of all, let us talk about what sour water is. This term refers to the wasted water that refineries tend to produce that contains hydrogen sulfide. It is common that such refineries reuse or dispose of this material through the process of stripping, which uses heat to strip the water from the sulfide and make it a harmless component. For our specific project, sour water is our main input stream. This water is considered a sour due to its carbonyl sulfide, ammonia, and sulfuric acid content. The interpretation of a plant consists of 11 equipments involving different components and streams, which are used to meet the objective. It is also important to note that an additional mixer was proposed as well as a stream coming from the hydrogenation reactor. In this unit, the remains of the carbon monoxide produced in the reaction are then sent to a new stream, which along with sulfuric acid and nitrogen will go to the battery limits. The main functions of the process include evaporation, separation, and a few chemical reactions, filtration. Initially, most of our data was given in mass fractions and additional relationships. From this information, we elaborated a mass table and then converted it to moles. Having additional relationships regarding conversions as such, the additional information was written into the new molar table. The next thing to do was to analyze the global degrees of freedom. The global degrees of freedom yielded 2 degrees of freedom, which meant that 2 bases were required to complete the table, hence solve the material balance. Knowing that our stream shows the amount of treated water leaving the process with a few remains of ammonia and sulfuric acid, the proportions of these two toxic wastes were evaluated. Our new slightly sour water is given its name due to its H2S and NH3 content. According to environmental regulations, the final treated water must have a content no greater than 20 ppm by mass of sulfur and 2 ppm by mass of H2S. Analyzing the material balance fractions, which resulted in 0.4699 of sulfuric acid and 0.3091 of ammonia. We find that these amounts meet the parameters set by Semarnat in Mexico. In conclusion, the main objective, which was obtaining treated water throughout a series of chemical processes, was achieved. The consequences of water treatment were inside the parameters, therefore it's environmentally friendly and it reduces the industrial fire risk, which is very common in plants such as this one. This process as a whole can be considered as a good one because not only is water being cleaned, but also it's profitable in the sense that the wasted material can be sold and reused.